Today we're going to be putting together a distributed validator. And let's start with a simple question. What is distributed validator technology? So basically it allows different nodes to be performing one or many validators' duties. What does this mean? That this infrastructure basically is more resilient because it removes single points of failure in validation. So if less than 33% of the participating nodes in a distributed validator cluster go offline, the active nodes can still come to consensus and keep performing staking duties. So the idea is that since solo staking, as many of you know, is like the gold standard of decentralization in Ethereum, however, has some points of failure. Like, what if I have a power outage in my area? Or what if there's a hurricane? This is what Distributed Validator proposes, to have better infrastructure and more decentralized, to keep performing staking duties without it being in the hands of just one or few operators. So in order to achieve this, Obol uses Karen. Karen is a client for distributed validators and basically is middleware software that pretty much brings together different nodes and helps them reach consensus. I was doing some examples of circumstances under which nodes are offline, but what happens if there is a client, an execution client, that gets an update and there is a bug in that update that is preventing nodes to run properly. So if there is client diversity within this cluster, as long as the majority of the participants in this cluster are not running and operating using the same client, this validator is going to keep performing just the same. How does Karen and Obol work? This works with a distributed validator key. Now, what is very interesting about distributed key is that instead of having a participant in the cluster produce a private key and then being trusted with splitting it and distributing it, there is a much better approach that Karen does, that is to never construct or put together the full private key at any point. It prefers to have every participant in the cluster have a small piece of this key. So the only way that this validator can be performing its duties would be if this key has a majority of its components to be able to perform these signatures. And how we generate one of these distributed validator keys is with a DKG event, which stands for Distributed Key Generation Event. This is an event where all of these node operators come together and they each perform a signature that is going to output this distributed key. So today we're going to be able to put one of these together because we are going to be doing a Holesky testnet distributed validator. So what we're going to need for achieving this is a Dappnode that is ready and configured. As you know, Dappnode makes the process of home staking much easier. We're also going to need a synced Holesky node, the Holesky Obol package, and operators. I'm going to welcome to the stage Bitcoin Louis, Max, and Greenpill. Max and Greenpill are also part of the Obol team.
Really excited to be here. This is important, especially as a lot more community clusters come on board for Obol DVs, and there's going to be a lot more Dappnode users in the future. So excited to do this training.
As I mentioned, the first thing that we need is a Dappnode that is fully synced. We can see here that we have Besu and Teku running in this Holesky node. And I also have the Holesky Obol package installed. We're going to start going through the Obol DV Launchpad. So today we're going to be creating a cluster with a group. there is really good and very well prepared documentation. So it'll make you go through each of these requirements and just in general information that you should be aware of if you are performing a DKG event. So let's get started. It's going to take us through what proof of stake is, some of the risks of doing this. We're going to accept. This is very important. Please keep in mind that this is beta software. So, okay, we're going to be configuring our cluster. Our cluster name is going to be Dappnode and Obol's Cool DB. As I mentioned, we're going to be applying a configuration of 3 out of 4. Another common question is, what are the differences between cluster sizes? There is really good information in the Obol documentation. So you'll find like a very simple, not as technical version of this that will tell you what are some of the features that some cluster sizes will offer to you. And then we have, in this part of the documentation, we have one that goes a little bit deeper into the technical explanations of these 2 categories that are classifying resilience in the distributed validator, which are the Byzantine fault tolerance and the crash fault tolerance. So basically, the Byzantine fault tolerance is nodes that are trying to disrupt the cluster, like bad actors. And crash fault tolerance is like one of the scenarios that I described earlier. So this is basically the difference that this number makes. So today we're going to be only 4 operators, but if anyone out there is running any tests or experiments with distributed validators, please let us know if what are some of your results and anything that you'd like to share about your DVs.
Yeah, just in the launchpad, you can hit plus on the cluster size and you can see how the threshold number changes. So basically, when you go from 4 to 5, the threshold doesn't change. Like what I mean is that in both cases, you can have up to 1 node going offline. So you don't have an advantage from going from 4 to 5. Since if there's 2 nodes offline, it'll take it offline completely, the validator. But if you go from 5 to 6, then you can have up to 2 nodes going offline. So that's why we recommend, either 4 or 6, because you're not really getting any benefit from having 1 extra node. So going from 4 to 5, I hope that makes sense.
Thank you for that explanation, Max. We're gonna move on with our operators. So today we're gonna have Max, Greenpill, and Bitcoin Louis join our cluster. So I'm gonna go ahead and add my address, and then add the address of our other operators today. Okay, so we have the 4 addresses. We are going to be doing the deposit for only 1 validator today. And then the launchpad is going to ask for this ENR. An ENR, or Ethereum node record, is a unique ID that Karen will give you. So if you go to your Dappnode Holesky Obol package, you'll see that you are able with this package to participate in 5 different clusters, and each of these clusters will give you a unique ENR. We're gonna go ahead and select number 2 for today's demonstration, and I'm gonna take this ENR, copy paste it here, and in the next step the other 3 operators will be doing the same and performing a signature with their operator wallets. But before we go there, there is this feature from the Obol Launchpad that gives you the chance to integrate a split contract. So how does this work? If you are the only operator for a DBT cluster, which can also make sense, you're probably going to be the only withdrawal address and also the fee recipient. But what happens if we want to be giving other operators a percentage of everything you earn? Then you would configure your split contract this way, where you'll have withdrawal address for your 32 ETH deposit, but you can also split it in percentages. So you can dedicate like a 5% or a 10% to each of your operators. And I really like this because this is where it becomes interesting, especially for communities that have one form or other of collaboration or public good funding in general. Again, this is the split contract that is integrated in the Obol Launchpad, and it also will give you the chance to split even the 32 ETH. Like, what happens if there are 4 operators and each of them have 8 Ether? So this configuration of the split contract will give them the chance to make a deposit, and whenever they are ready to exit the validator or withdraw, or just in any regular withdrawal, these rewards will be evenly distributed as configured by the operators in this part of the process. So for the sake of being a little bit quicker with this demo, I'll just use my address today. Again, this is in the Holesky testnet, so even if you are planning on running and operating a distributed validator cluster, you can start by configuring this in the Holesky testnet. This way you won't be risking any real funds. So now we are going to need to confirm our configuration, which is going to be a 3 out of 4. And we're going to have these 4 operator addresses. We're going to be depositing the total for 1 validator. This is my ENR. And this is the withdrawal configuration that we are going to be following.
So some people were asking why there's multiple ENRs shown in the Dappnode, and basically you can take part in multiple DV clusters using the same Dappnode. That's not a problem. So in this example, you're using ENR number 2. Maybe that just means that you've already used the first one for a different cluster. But yeah, that's not something that people have to worry about. There's also questions about whether it's possible to run more than 5. I think in theory it should be. I think it might be possible to generate more ENRs in the CLI, but I'd have to ask our devs. And I'm also maybe a little concerned if you ran too many that maybe your performance, your hardware might start to get taxed, used heavily, and performance might go down with very high numbers. But that's something I'd have to ask the dev team and get back to you guys. There's also one question about the difference between Obol and SSV. We do have a blog post where we kind of talk about how we built Obol and the design decisions. Long story short, we didn't build a validator client, we built a middleware, whereas the SSV client is a validator client, so it has keys and it's signing. Our middleware is just sitting basically underneath the validator client, and it's not signing anything itself. The validator client still is the one with the access to the keys and does all the signing. So we think our solution's a little bit safer. But yeah, go ahead and feel free to check out that blog post.
Okay, I think there are no more questions, so I'm going to go ahead and sign my ENR. Oh, there we go. Okay, cool. So now that this cluster has been created, it'll give me an invite link that I'll have to share with the other operators. So we're gonna go and check operator status. Okay, so what is going on at the moment? Each of these operator addresses will need to also submit a signature with their ENRs. This way, the nodes in our cluster are gonna be able to talk to each other. And this way is like adding a node peer in a safe way and only granting this to the operator address. Okay, so we have all of our operators. So we're gonna continue to the DKG, and doing this is very, very easy with Dappnode. So we're gonna go back to our Obol package, and we're gonna go to the configuration. And here we'll need to paste in ENR cluster that we used. This is where we're gonna paste this link, which we'll be able to find here. So I'm gonna copy this link. I'm gonna paste it in cluster number 2, and I'm gonna update it. So after this, I'm gonna go to the logs. And so far, we have 2 out of 3 peers connected. So what the other operators are gonna need to do is to basically take the same link and add it to their Dappnode package. So I think I'm only missing one. I think that's Bitcoin Louis, but let me send you the address that you'll need to paste.
In the meantime, in the chat, there's some questions around the setup, like what you can do, different ways you can use this. So to be clear, like you can do this with multiple people. So for example, today, we're 4 people. We could split up the principal and the rewards so that each of us puts in 8 ETH and we split the rewards evenly. We could also do it that, for example, Chewy puts up the 32 ETH himself, and the other 3 of us earn some of the rewards, like a certain percentage that we would agree on. So it's flexible in that regard. Also, it's possible that you can run all of the nodes yourself. So if you want to stake your own ETH and you just want to use DVT as a way to like boost, the robustness of the validator, you can also do that. But it's definitely worth saying that, before you run on mainnet, you should definitely run on testnet, just to get yourself comfortable. So sessions like this are useful. You can run up to 1 validator on mainnet using the launchpad today. It's still in beta. So, there's some questions about, when we'll be on mainnet. We are on mainnet already, but we haven't officially launched our version 1. Hopefully that will be coming in the summer.
So if you're watching my screen, pay attention to the logs, because when the 3rd out of 3 peers connect, then Karen will take care of this DKG ceremony.
Okay. Just added the definition file and it's updating now.
Okay, great.
Okay, let's go.
Oh, there we go. All peers connected, starting DKG ceremony. And we have keys, everybody.
Happy days.
Okay. Okay, great. So now that we have distributed key, I'll go back to the launchpad, and it's gonna remind us to create a backup. So the way you create a backup is you go to the backup tab. It is very important that you save your key in a safe place, because as I mentioned, the key itself is never going to be like a single key. It's always going to be split between, in this case, the 4 operators. So if anything happens to any of the devices and we need to restore this part of the key to the cluster, we're going to need a backup of this portion of the key. So if you're part of a cluster and don't have a backup, please do that immediately. That's how you back up with Dappnode. And in case you needed to restore it, you just click on restore and upload the same zip file. And yeah, that's it. So it's asking me to confirm cluster health. So let's continue to the deposit. And then it's going to ask for this deposit data file. So I'll be able to find this in the backup that I just made.
By the way, there is a question in the chat that you could explain a bit more about backups and how to safely back up the keys and what exactly you should be backing up.
Can you talk more about backups? How do we make sure the keys from the DKG ceremony don't get lost? Do all 4 clusters need to have a backup? Is there any other way to recover the keys in a disaster? Yes, that's a great question, GBeast. As part of the responsibilities of every operator, the right custody of this key is part of the basic responsibilities. But let's say that in 3 out of 4 cluster configuration, one of the operators loses access to the key. You will be able to broadcast an exit message if you meet the minimum requirements of the cluster configuration. So let's say that 1 out of 4 is missing and it's missing their keys. So if there's absolutely no way to get the keys back, you will be able to broadcast an exit validator message from the 3 active operators. In this way, you can secure the funds and then restart another DKG and just make another deposit, another validator. So yeah, it's I mean, it's not that it's gonna be like completely lost, but it's not like the most convenient measure. So yeah, it's always gonna be best. It's like keeping good care of a private key. So I just decompress the zip file with the backup, and inside I'll find 5 different folders, one for each Caron cluster. And there I'll find the deposit data JSON file that now I'm going to drag and drop to the Launchpad. And I'll click continue in my wallet. So I understand the risks. And perform the signature for depositing 32 Holesky ETH.
This is exactly the same as a normal validator at this point. There's no difference. The Ethereum protocol thinks this is a normal validator. It doesn't even know that this is a distributed validator. So there's basically some discussion about, we mentioned that it's possible to have, for example, a cluster of 4 participants where someone is putting up the entire 32 ETH themselves, and there's some concern around, let's say you put up the 32 ETH and then the other 3 guys lose their keys, their nodes go offline, and basically now you can't get the threshold of 3 out of 4 that you need to sign an exit message and give the ETH back. That's true. That's a bad situation for sure. So I think pre-signing exit messages and sharing them should be possible. I'm not actually sure. I need to look into that. But yeah, I'm glad that everyone is at least understanding the risks.
There's definitely a lot of room for improvements, especially in the trustless part of this technology.
This is why it's really important that if one, let's say you're a cluster of 4, right? If one operator tells you, hey, my node got destroyed and I don't have a backup, that's why you need to exit right away, because you can still exit with 3 out of 4. But if anyone else loses their node and doesn't have a backup, then you have a problem. So yeah, this is why, even in bigger clusters, let's say a cluster of 7 where 2 people could have their nodes destroyed and lose their keys, even in a cluster of 7, I would still say if one person has that happen to them, you should still exit. So what we're wanting to build in the future, what we're building for the future, is a system where you can swap out operators without actually having to, exit the validator, create a new validator, deposit to the new validator, right? And that's also going to be really useful for permissionless LSPs like Lido, where one person becomes unresponsive or just generally is not professional, or if they have bad uptime, you can just basically use the threshold of the other people to say, hey, you know what, we don't want to work with this guy anymore. We're just going to swap him out for somebody else. And you don't have to shut down the entire validator and go through the whole process of creating a new validator. But, that's coming soon, TM.
I highly recommend that if you're interested in running an Obol cluster, you need to set up good and efficient channels with the other operators. If everything from Discord server to a Telegram group, whatever works for the operators, it's great to have efficient communication channels for this. In the end, this is the human coordination layer of all of this stuff. So I would highly recommend that you start this channel even before your DKG, so that it is well established and all of the participants can be familiarized with this communication channel. To get the most out of a DVT, I would say that this is probably, out of everything that we've been through today, this is the most important part, the social coordination layer. I would say that try to invest as much time on this as possible. Also, we just released the newest version of ethical metrics in Dappnode, so you can also get notifications if one of the DApp nodes in your cluster is offline. You can also send those notifications to a Telegram group. This way, not only the operator finds out about it, but everyone else is in the same channel. This is something that I would recommend. And also, if you're a little bit more of an experienced user, if you have some experience with Grafana, with Prometheus, a dashboard that everyone can be following, don't go light on this coordination layer. Try to also, especially if you're going to be running a cluster on mainnet, try to run this same coordination channel with a distributed validator on a testnet first, so that you know for sure that this is the most efficient way to remain in contact in case anything goes wrong. And also, other than this, good operator practices. Be gentle to your nuke, keep it in a safe, ventilated place. Don't let it run too hot. If you've been running your Dappnode for more than 1.5 to 2 years, change its thermal paste, dust off the fans, check that everything is going all right. Like, all of this would be more of like traditional node operators, good practices. So this is also something that I recommend not going light about.
Yeah, just some questions around how to get involved. Unfortunately, I think it's too late to apply for the Lido Simple DVT. It seems like the form for EtherFi Operation Solo Staker is still up, so definitely fill that in. Otherwise, on our side, what we can do is we can offer Techni credentials for people that show that they can run with good performance on testnet. I linked to a blog article, which is a little old now, but will actually be kind of revamping the Techni credentials soon. So keep an eye out. But yeah, I mean, look in our Discord for people to run with you on testnet and earn a Techni credential at least.
Okay, exiting a DVT with Obol. I think this is the last part. And I'm going to go back to the documentation and exit distributed validator. So it's pretty much broadcasting a message. The Dappnode Obol package has Lodestar built in. So you just need to take this voluntary exit and then copy it and paste it in the advanced configuration as well. So let's say that I want to exit this validator that we just created. I would go to validator extra ops and I would update the configuration. So that would be 1 out of 3 necessary for broadcasting the exit message. And that's it. This is how it works at the moment, but we hope to have a more practical implementation of it. Maybe easy is not the right word because we don't want any accidents to happen. Kind of like how it works with Web3 Signer at the moment and with the staking brain. If you exit any validators that you selected, you'll need to type in the I want to exit confirmation message before it actually goes through. Just to close this Dappnode Crash Course before we go to the Q&A section of this, check out the Lido Simple DVT testnet applications. try to apply if possible, and also the ETH Stakers program. Please do so. This is the whole point of being an efficient operator without having the necessary funds to be a solo staker. So please do. We would love to see many node operators from the Dappnode community get to be good and respected members of different clusters. That's it for today. That's it for this Dappnode Crash Course. Thank you very, very much to everyone that attended.